Howdy, Cape Codders. Welcome to another show. This is the Scannell Agenda. My name's Stephen J. F. Scannell. And the date is July 6th, 2015. And this is show number 24. The title of the show is Water Systems. The last show I did was entitled National Water Project. Now I'm just going to gab about generalized water system philosophy. Here's one of my doodlings, and this one is about something that's more advanced than we usually think of. This is called a deep water table pollution pusher. So we would cite a windmill water tower combination with a deep well, and then we would discharge from the water tower water into the well down beneath, so we would be getting under the water table pollution, and we'd be pushing it up possibly in several different ways, and shepherding this polluted water to a location where it can be siphoned off. This is not even state of the art yet to be able to do this. So this is how to do it. It is to site these windmill water tower pumps. Where you have the worst pollution, get under the pollution, push the pollution where you want it. This is new stuff. It would be groundbreaking technology, I suppose, if we got into it. This is the kind of thing I like working on. I've never heard of it being done. So this would be for long-term cleanup of any polluted area. Come to mind on Cape Cod, maybe several different small sites that you might think of that are polluted from industry or a military base or what have you. Could be small, could be large. So this is long-term cleanup. So we want zero pollution inputs into the water table, so we don't have to spend money like this. So in the future, and I know we're really working hard now not to pollute the groundwater, which is good. The other half of that equation, though, is to find and seek out the polluted hotspots, kind of corral them and pump them out as best you can. These are expensive systems. Now I mentioned that these water systems too overlap into farming and aquaculture and sewage. So there's a lot to these water systems. And I try, and some of my stuff is like what's called a Rube Goldberg, you know, and that's what I'm looking at now. I don't even want to tell you. It's an Archimedes spinner water lift. It's foolish, but you don't hit the ball every time. You know, sometimes you strike out. So it's like, okay, once in a while you get a dud, you know. And it looks like a good one, but it's just full of mud. You know, so sometimes I'm full of beans, and the idea is, with my system of a ratio of good ideas, I work on a 30-to-1. One good idea and 30 bad ideas, or kind of like, what? You know, please. You know, I've got them all. A stack of them taller than me, of this stuff here, which is not impressive unless you did pull out the good ideas, and that would be a small stack, maybe, if I'm lucky. Florida stormwater for oysters. Here's a project I was working on before I went down to Florida this last time, because they're having problems with their water down there, Okeechobee, you know, and I was in the Port St. Lucie area. Not that I really studied their problems, but basically they're looking at algae blooms, etc. So you want to pump or pull with gravity your storm water. You want to be able to clean it up. You want to be able to transport it and hold it, for instance, in bags under the sea as a reservoir. In Florida, to create your reservoirs, you may be wise to do a lot of underwater water storage. Maybe not. But in Florida, water storage is problematic with that hard marl ground. You got to really, it's very difficult. It's not like sand on the Cape. So you want to freshen the oyster beds at sea every once in a while with that water, because if you think about the mitigation of global warming, having rain events that are sporadic, and then having a possibility of really good ecosystems in your estuary environments in Florida, you want to be able to control water, fresh water, salt water. So these are things we can try on a small scale, but before that we would obviously model them up. Computer models, draw them up. And I really would love to have, if anyone's listening, I would love to have artist renderings of what I do, just so, you know, so you can visualize. I do a pretty good job of visualization, but it's for me. I need you to visualize my visions on water systems and everything else. And for that, you need artistry, and I'm not the artist, believe me. You've seen my stuff, but I don't claim to be the artist here. So you can use fresh water too as an inoculant in salt water. That basically, things like, okay, in the old days, your wooden boats would go up into the fresh water, and that would take care of the shipworm. But you can do the same thing. You can travel with a movable reservoir over some bottoms that you would want to be brackish. You can move over those bottoms with a corral, let's say, of fresher water, fresher salt water. And what that would do would be to knock your predators out, and then so you could raise oysters and what have you. These are not to substitute for Mother Nature, but Mother Nature had it pretty good, and right now we really don't. And so we need to re-engineer some of Mother Nature with the mindset that we're just helping you out, Mom, with Mother Nature and all these terrible crises that we're suffering with global warming and catastrophes. We just need to make some minor changes with salinity, for instance, and many other things. So here's a Plains Canal that I have. This is a water system of variable depth, which would run from Canada down to Texas. And it's under the sea. I don't think you can pick up on that, but that's all right. I should be, if I were a professional person, I'd have these darkened up, put on a web page, and I would be following the orders of my college professor Lee and doing concise reporting and good oral communication type work. And I'm so sorry, Professor Lee. I'm just, you know, you can deny you ever had me as a student at Cape Cod Community College. The work I do is very low level. All right, Plains Canal, north to south. So you build by cutting in high areas, and then you build up the low areas, and then you have locks. So water systems includes canals, canal systems. Ditch flows regulated by dam, and here's one that says water systems, and it also says PE, which means pilgrim evacuation. So here we have a ditch regulated by dams that would be a cranberry bog area or a low area. Most of your low areas, chances are they probably had a cranberry bog that's now defunct. If you see old ditches, that was a cranberry bog, most likely. So this particular system here is designed for a lot of ditches and flows that take different paths depending on what you dam up. alternate the flow to these designed as river, not just a ditch, so you meander your ditches for a gradual drop. And then you can use the chute or flush to clean out these areas. I think a big industry on Cape Cod in the future should be watercress. And for speaking of the Pilgrim evacuation, one of my best works is with it's like a 10-sided boat, but it's not a boat, it's for growing watercress. And this is what we'd clean out in a hurry. It would go to a clean out station. People would pile in, and the people would go down these small river systems and out into Nantucket Sound, let's say, and then out into some real boats. More about the Pilgrim evacuation later, but that's coming along. Here's an old boat, water and shade. So, I mean, it runs the gamut. I'm going through my water system file. This is to use an old fiberglass boat as a cover for a water tank. And the water tank has a cistern. This is for feeding livestock. Here's a water saver canal, which is it's a newfangled thing I just talked about. This is for, let's say, a water saver canal would be for dry areas where you wanted to have the ability to use your canal as a reservoir and to use it for transport of cargo. And there's a tug in the canal, which is a pipe with an opening, and the canal has wheels on the bottom. So none of this would be cheap. Water systems such as, what is this? All right, pancake grow bag water system. This is for greening the earth. It's for using canal water and having the water on hand to put into a canal, as I mentioned, is a factor of the TRIPE system, the Unified Utility Grid System. So assuming we can get water to where we want it, we're going to need designs as to what we're going to do with the water. So this is a water bag system to capture water and green an area using little mini bags and grow bags, and conservative with the water for dry areas like Texas, Oklahoma, Colorado, Sub-Saharan Africa. What's this? Niagara Falls water lift. Water systems, nuclear plant, water towers, 100 towers at 400 million gallons each. This is something as a pumped hydro system for the canal, for the Niagara Falls area. So it's a Niagara Falls water lift, and it's got several stages of conveyor belts to haul the water up. And then as you want the peak power, the conveyor belts would supply the power as a dynamo would in the opposite direction to generate electricity. So I was pretty impressed with that. I don't think that's a Rube Goldberg, because pumped hydro is not getting the credit it deserved, or the tax credits. I was listening to Congress. These pumped hydro systems that work in conjunction with the wind should be greatly favored by our United States Congress, and I'm finding out, no. I mean, this is, if you can use windmills in conjunction with pumped hydro, this is off of your standard electric grid systems, and then they can power in a pinch with the stored hydro. That's really where it's at, but I have a feeling we're battling the dinosaurs here. And what would make sense that we do? which would be to heavily subsidize pumped hydro wind, pumped hydro / wind, well, we're not doing it. It would make all the sense in the world to do it. If we're not doing it, there's got to be reasons Congress doesn't want it done. And I would just probably guess that one of those reasons would be, you know, the dinosaur power producers of today, coal, natural gas plants. They wouldn't like to see this coming along. It wouldn't benefit them. So, foot on the brake, right? Woven basket, water tank, reservoir. These are designs for reservoirs from the janitor at the boat shop. That's me, designing a reservoir. So this is work with lamination, wood plastic laminations. You know, if you had a woven basket, it looked like a woven basket, but it was using the 128-foot wide, 8-foot diameter wood pipes as your basket material, which is way out of scale. We never do things in this scale, but it could be done. You would start small, and if that were a sensible concept, then you would scale it up. Sometimes I scale up too quickly, but that's my job. Water level and step-up theory. Okay, the water level as a mason's tool, the water level. The pipe diameter is a function of the tank and the volume and the ability to keep up and then not to waste. If you build pipes that are too big and you're trying to push water through a pipe that's too small, let's say, or these are all. My dad, by the way, was a pipe fitter, second class in World War II. My mom outranked him. She was a first lieutenant in the Army. Of course, Army, Navy. That was fun, you know, to goad mom and dad. We're looking for speed. So if we're getting free rein, we're looking for speed to capture that water. We're looking for systems to drain the water, capture the water, pump the water into close-by reservoirs, which can be used as, you know, you could use that as a football stadium. You know, you could use these, you know, if you had a reservoir, you could keep water in it and go swimming and that kind of thing. So we're looking for speed. We want to move water fast. These lows that come in and dump a bunch of water. We want to be able to move fast and get the water. We want to size the systems properly. That's the job. So it's like a puzzle. It's like working on a puzzle. To size these systems properly and have the ability to use common sense engineering-wise and say, you know, we could build a bigger system here, but, you know, how are we going to need it? And, you know, you factor in all the rain events, etc. Okay, at sea, false slope, rain catch. What is this? Another Rube Goldberg? Probably. Photovoltaic on water tower, ball and socket. So that's a way of, I thought that was pretty clever, a way to use your water tower as a major photovoltaic. What it is your, let's say this scallop here is your, or here, this is your water tower, that's even better. So, and here's your bank of PV, and here it is in the sun in the morning. So, and these are wheels down here. So your PV array moves around, and then in the evening, it's right there. And so back you go for the morning sun, and this is your water tower, but you're using the water tower just as a, it would be big. So it'd be pretty easy to construct on a small scale. It'd be pretty easy to model up. So that's a photovoltaic on a water tower with a ball and a socket, so that your PV is always pointing right into the wind. That's pretty clever. So that would be a solar idea. Maybe I'll go through my solar file. Here's a neighborhood cistern system for irrigation of local and national effort, non-potable uses. In other words, you have different breakdowns of what your water is, different grades of water. So you'd have basics, you know, high and low. You drain from high to low, pump to high, and you want large mains, water mains, very large water mains with the ability to pump water through these large water mains at very high pressure using compressed air. However, these water mains wouldn't be justifiable just as a water main. You'd have to use the water main also as a pneumatic tube. And then using the pneumatic tube, you just hopefully remember to stop using it as your pneumatic tube and empty it out and say, okay, we gotta, you know, your water events, your rains are pretty easily seen on the radar. It's amazing what they can predict on them. The meteorologists, I take my hat off to you. It's just amazing, because I grew up here in the Cape, and we didn't know what the weather was going to be. We didn't have these long-range forecasts at all when I was a kid. But you meteorologists, you've broken new ground, you're saving a lot of lives. 2% food tax to water systems. Now, if we're using water systems and they're running at a great cost, we're going to want to recoup that cost. And if we recoup the cost on food systems, let's say a 2% tax on food, this is like attacking, if you talk about a food tax, it's like attacking Social Security. Maybe I'll get over this, but these are comprehensive systems. And, oh, by the way, speaking of food tax, I was on national TV, I mentioned, on a radio program for C-SPAN the other day, and they were talking about, this was 2 days ago, they were talking about the kind of like a sin tax, although they didn't call it a sin tax. They were talking about a sin tax for the sugary foods. And I called in and I said something to the effect of, I'll try to get it to replay it for you. Something to the effect of, you know, my system designs incorporate both a recycling system and a healthy soil and food system dovetailed together. Now, a healthy soil and food system would merely incentivize the good food and then penalize the bad food. It's just like the market quota system. So it's a market quota system of food management. Not that we want to manage people. I'm kind of a libertarian, but I think that if it's presented properly, then libertarians can go along with, let me qualify that. If the libertarian is with the reality of today, that actually the government's paying for a lot of health care. Now, if that's a stumbling block, because that's the way it is. We have a health care system that's borne by the public. The cost is essentially a public cost for many people to have health care. Okay. So being that a lot of people just don't have the gumption or the intelligence to do the right thing and eat right and live right, and, you know, well, shouldn't it be that we recoup some of these costs? Probably, yeah. Now, to do that, if you put a 2% tax on some of the bad foods and you put that towards a water system, that might make sense. So I'm thinking a food tax wouldn't necessarily be for, you know, things like kale that is organic. You might want to subsidize organic kale. So that would be the two. My thinking is, and it has been over the years, that we subsidize what we do like to a certain extent, And then we penalize what we don't like, you know, to a certain extent. We don't go overboard. So 2% food tax to the water systems would make sense. All right, I'm just going to keep going with these water systems here on the next show. So thanks very much for watching Scandal Agenda. On Cape Cod here, we're very lucky. This is the town of Dennis. Tap water with my cranberry juice. Cape Cod's always had the best water. Thank you, Dad. Here's to you, Dad. And all the World War II generation people. And my dad down in Florida, my wife's dad. Here's to you. All right, thanks for watching the Scandal Agenda.